Welcome back to my chemistry lessons. Today we are going to define an atom um, and the nucleus and the energy levels. So as we know, atom has a central part, and the central part of an atom is called nucleus. And the nucleus consists of protons and neutrons. And this is the entire mass of an atom. So generally, electrons are not contributing anything to the mass of an atom. So mass of an atom is the total number of neutrons and protons inside the nucleus of an atom. Neutron has no charge. At the same time, proton has positive charge. So nucleus has positive charge because of the positive charge of protons. So inside an atom, the central part of the nucleus carrying positive charge and the negative charged electrons are surrounded by that nucleus in a certain fixed energy values, and that certain fixed path of an electron around the nucleus is known as orbits or energy levels. So this concept was introduced by Niels Bohr. Niels Bohr conducted a spectroscopic study on hydrogen atom in its ground state and in its excited state. So a hydrogen atom receives a certain amount of energy, and that energy is used to jump the electron from one level to higher level. So because of that amount of energy, hydrogen atom exists in a certain state that's called excited state of hydrogen atom. After some time, or in certain conditions, the excited state of hydrogen atom allows the electrons come back to its original level. So basically what happened is, due to receiving of a certain amount of energy by a ground state hydrogen atom, the electron in its particular energy level jumps into higher energy level, and certain other conditions, the electrons come back to its original level. At the same time, a certain amount of energy liberated. So when this transition of electron taking place from higher level to lower level, certain amount of energy liberated. So in emission spectroscopy, we will get a particular line in that spectroscopy that indicates certain amount of energy emitted. The same way in absorption spectroscopy, if the electron absorbs a particular amount of energy and goes to higher level, so this transition of electron from one place to another shows another line in the absorption spectroscopy. So this absorption spectroscopy and emission spectroscopy gives a detailed idea about the energy levels in an atom. So Max Planck conducted a detailed study on it and made a relationship between the energy levels of highest or excited state of an atom and the ground state of an atom. And he showed that the energy difference between highest and lowest energy levels is proportional to the frequency of the light used. So let E2 be the energy of the excited energy level and E1 be the energy of the lowest energy level. That means capital E2 be the energy of that particular electron when is in its excited state, and E1 be the energy of the same electron when in its ground state. So according to Planck's concept, capital E2 minus E1 is equal to h nu. Here h, small letter h, is known as Planck's constant. It has value 6.626 into 10 to the power of minus 34 joule second. So in absorption spectroscopy, definite lines shows the clear evidence for the energy levels in an atom.